Hello everybody and welcome to the review videos for cumulative review number 15. Let's start here with number 1, where I'm asking you to first list all the possible rational zeros of the function, which help us before we graph it see what our options are. And if we'd like to do this, all the options are from plus or minus p over q, and to remind you, the p value is the n term and the q value is the leading coefficient. And so what we do is we take the factors of the p term divided by the factors of the q term. So all the factors of 20 would be 1 and 20, 2 and 10, and then just 4 and 5. All the factors of q would be 1 and 2. So we have plus or minus 1, 2, 4, 5, 10, 20 over plus or minus 2. On the answer key, the answer was left like this, but technically we could write out all the different answers just so you understand again what this really means. So we would take every number on top and divide it by 1, and then take every number on top and divide it by 2. So if we did that, we would get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and then plus or minus 20 if you divide all of those by 1. Then if you divide all these by 2, other possible answers would be plus or minus a half, plus or minus, well, if I took 2 divided by 2, that's 1, which is already there. And then if I took 4 divided by 2, that's 2, that's already there. 5 divided by 2 is something we don't have yet, 5 halves. 10 divided by 2 gives me 5, and 20 divided by 2 gives me 10. So it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible rational roots. We will accept either answer on the test, but I want to make sure to show you the blue version just so you understand what's going on. The reason it's useful is because now if we're asked to find all the zeros or the actual zeros, what we tend to do is graph it. So what I already did here on Desmos was I graphed the function. You can't see it all over here, but this is a picture of my graph, and feel free to pause and graph it on your graphing calculator, see if you get the same thing. If you do, it looks like I have 2 zeros at 1/2, 0, and 5, 0. And so what I'm going to do is go with the easier one to work with, 5, 0. And I want to come back to my problem. And if I'd like to find all the zeros, I look back at my original problem and ask, first, can I factor this? Well, if there's 5 terms, I cannot factor by grouping. But what I can do is use synthetic division, reduce this degree of this polynomial, and then continue to factor it. So I'm going to take that 0 of 5, and I'm going to use synthetic division. This time we do not have any missing coefficients, but if you did, remember that you have to put a 0 here somewhere. So if I perform the synthetic division, bring down the 2, multiply, combine, multiply, combine, multiply, combine, and lastly, multiply. When you combine to be 0, that means that my remainder is 0, which means this is definitely a 0. If I couldn't graph it, I know it's a 0 because of no remainder. So from there, we can continue this problem one of 2 ways. One way is to remember that you reduce the degree. So this becomes 2x cubed minus 1x squared plus 8x minus 4 equals 0. And you can continue to factor by grouping if you'd like. So you'd group these together, take out a greatest common factor of x squared. You'd be left with 2x minus 1. Take out a greatest common factor of 4, also left with 2x minus 1. So that means I'd have 2x minus 1, x squared plus 4 equals 0. And if I solved both of these, I would get x equals 1/2 if I set this equal to 0. And if I set this equal to 0, I would get x squared equals negative 4. And if I take the square root, my answers would be imaginary, plus or minus 2i. So if I did it the first way, my zeros would be 5, 0 from here, 1/2, 0, which we knew already from the graph as well, 2i, 0, and then negative 2i, 0. Now, I would like to point out again that because the highest degree was 4, it makes sense that we have 4 possible zeros, and again, some of them can be imaginary. Let's say that you didn't like this method, and you did the same thing up to this point. Let's say you plugged in the 5 and you got this remaining polynomial. Let's say instead you'd prefer to use the 1/2 and do synthetic division again. So if I come back here, and let's start at this stage right here. So I would do 1/2 into 2, negative 1, 8, negative 4. I would do synthetic division again from here. And again, this is assuming that you started with 5 again. Bring down the 2, multiply, get 1, get 0. Multiply, bring down the 8. Multiply, get 4, bring down the 0. Get that 0, which means this is definitely a root again. What I'd be left with is, if I reduce the degree, this was a cubic, so this is now something squared. So you have 2x squared plus 8 equals 0. And if I solve this for x, I would get 2x squared equals negative 8. Divide by 2. So I would get x squared, sorry about that. I would get x squared equals negative 4. So yet again, I get the answers of plus or minus 2i. So again, it's completely your choice. You could, after the first synthetic division, do factoring by grouping, or you could do synthetic division twice and end up with the same answer. Either way that you do that problem, your answer for part C will be the same. If you'd like to write all the answers as a product of linear factors, that means the highest degree of each has to be 1. So the linear factor of the 0 of 5 comes from x minus 5. The factor of 1/2 is not x minus 1/2. It's going to be 2x minus 1, which actually comes from, if you factor by grouping, this piece right here, because this is what you said equal to 0. The other two would be x minus 2i and x plus 2i equals my function. I know that took a little bit, but I wanted to remind you about all the ins and outs of this problem. Number 2, solve each equation. So both of these are from Unit 8b, and it's been a little bit since we've seen these, so I think it'll be good to put them on this review packet. So the absolute value of x squared minus 4x equals 3x minus 6. You might recall that whatever is inside the absolute value could originally be positive or negative. So we have two options. If the inside is originally positive, we have one option, and if the inside is originally negative, we have another option. So if it's positive, we assume that x squared minus 4x is positive, and we set that equal to 3x minus 6. However, if the inside is negative, because if I take the absolute value of a negative, it still comes out as a positive, we would symbolize that as negative x squared minus 4x equals 3x minus 6. So again, we change the sign of the inside and not the outside, because this is what's changing sign within, because you could have a positive or negative within absolute value. So what we do here is solve these both separately. If we solve the green one first, I see an x squared, so I'm going to move everything over here to this side to equal to 0. So we x squared minus 7x plus 6 equals 0. Let's see if this factors. X times x is x squared. 6 times 1 is 6. Negative 6 and negative 1 combine to be negative 7. So that factors. So my two possible answers are 1 or 6, and we'll check them in a bit. The blue version, if I distribute the negative first, I would get negative x squared plus 4x equals 3x minus 6. If I get these to the other side, I would get negative x squared plus 1x plus 6 equals 0. But I'm going to make this x squared positive, and so I'm going to divide everything by negative 1. So I would get x squared minus 1x minus 6 equals 0. And let's see if this factors. X times x is x squared. 3 times 2 is negative 6. To get a negative 1, it's a negative 3 and a positive 2. So two possible answers here are 3 and negative 2. So that's the first couple steps. Now we need to check to see which ones work and which ones do not. So we would take all of these separately and plug them into the original equation. So if I take 1 and plug that in, we change that to red. We would get, does the absolute value of 1 squared minus 1 times 4, or 4, does that equal 3 times 1 minus 6? Or does the absolute value of negative 3 equal 3 minus 6, or negative 3? No, it doesn't, because the absolute value of negative 3 is 3. 3 does not equal negative 3, so this is out. If I plug 6 into the original, does the absolute value of 36 minus 24, does that equal 3 times 6, 18, minus 6? So 36 minus 24 is 12. Does the absolute value of 12 equal 12? Yes, it does. So x equals 6 works. if I take 3 and plug it into the original, does the absolute value of 9 minus 12 equal 9 minus 6? Or does the absolute value of negative 3 equal 3? Yes, it does. 3 equals 3 is true, so this one works. And lastly, if I take negative 2 and plug it in, does 4, and then if you plug a negative 2 in, be careful, that's negative 4 times negative 2, so that's really plus 8. Does that equal 3 times negative 2, negative 6 minus 6? Well, the absolute value of 12 is 12. Does 12 equal negative 12? No, it does not. The two answers are 3 and 6. Number 3, this is a square root function or a radical equation. And if we'd like to solve this one, you would like to always get the radical to be isolated first. So the first thing I'm going to do is move x to the other side. And so I'd have the square root of 43 minus 2x, all under the square root, equals 4 minus x, because these are not like terms. Now, at this point, we cannot move the 2, we cannot move the 43, because they're all underneath the square root. So what we have to do is square both sides. So on this side, these inverses cancel, and you're left with 43 minus 2x equals. Now here's where you need to be careful. Remember that something squared means the number or the thing times itself. So it's 4 minus x times itself. So I'd have to use FOIL at this point. So over here, I would get 16 minus 4x, and then another minus 4x, which is minus 8x, and then negative x times negative x is positive x squared. And I'd still have 43 minus 2x over here. I see an x squared, so again, I know I need to factor, so I'm going to get these two over here. So I'm going to subtract the 43 to the other side, and at the same time, I'm going to add the 2x to the other side, so that I have 0 over here. So I have 0 equals negative 27 minus 6x plus x squared. I'm going to switch the order of that, though. 0 equals x squared minus 6x minus 27. Sorry about the pen, it's freaking out a little bit here. So if I continue this, and I'm going to see if it factors, 0 equals two numbers that multiply to be negative 27 and add to be negative 6 would be 9 and 3, negative 9, positive 3. So I have two possible answers of positive 9 and negative 3. Now, one of these works, I believe, and one of them does not. So let me think about it. If I take 9 and plug it back into the original equation, and I mean the original before I did anything, I would get, bring us down here, I would get does 9 plus the square root of 43 minus 18 equal 4? Well, that would be, if I move this down, that would be 9 plus the square root of 25. Does that equal 4? Does 9 plus 5 equal 4? No, it doesn't. So x equals 9 is not an answer. If I plug in negative 3 into the original problem, so that would be, does negative 3 plus the square root of 43 minus negative 3 times negative 2, so that really becomes a plus 6. Does that equal 4? So does negative 3 plus the square root of 49 equal 4? Does negative 3 plus 7 equal 4? Yes, it does. So x equals negative 3 is an answer. And it's tempting to think that it's not an answer because it's negative, but this time it worked. So it's always good to plug in and check. Okay guys, so this video is just going to be numbers 1 to 3. There was a lot of work that went into each of these. The next video we're going to continue with number 4. Thank you.